MTDCNC have been lucky enough to be invited to Newquay Airport, where they're doing a test run of the Bloodhound SSC. Now, it's going to be difficult to get shots today because, as you can see, there's media absolutely everywhere. But we're looking forward to watching later on and get some great footage. But a big thank you to FBC Manby Bowdler, who are sponsors of the car, and we look forward to get some great interviews later on in the day. Andy, appreciate your time. It's a fairly busy day, I should imagine. Now, I'm going to do something a little bit different here. I'm going to do top trumps on you because I bought myself a nice, speedy little sports car. I think I'm a little bit, faster than that. So, first of all, brake horsepower on mine, around about 200. What about the Bloodhound?
Slightly different measure of power here because, of course, we're using thrust, so it's equivalent thrust horsepower. But if you actually take the power out equivalent of the car, you've got 200. This car, 135,000.
Okay, you've done me on that one. Okay, then I'm thinking my car 0 to 60 about 6.5 seconds.
0 to 60 in this car here, as you see it, Cornwall Airport, Newquay today. 5-ton car, 90 kilonewtons of thrust. So from stationary, the car will be doing 60 miles an hour, 2 seconds.
Okay, done me on that one. Now, what about, obviously on a private road, I wouldn't be doing it on public roads. Flying mile, I reckon I could do it about 45 seconds.
Flying mile for this car, we're aiming to set the ultimate record, 1,000 miles an hour. That breaks down for a mile, 3.6 seconds.
Right, you've done me on all three there, probably not really a surprise. Thank you ever so much and good luck for today.
Thank you very much.
History in the making today, Gareth. Why is this event so important to you?
So we're predominantly an engineering, manufacturing, training provider, and as you can see from this car behind us, the level of engineering and manufacturing that has gone into this is absolutely unbelievable. It's a massive showcase for UK engineering manufacturing. We want to instill the confidence and the want for people to come into this industry, boys, but we're also looking at getting young females to get the uptake to come into engineering, and this should be the showcase for doing so, taking it into schools and showing everybody what we can create here in the UK.
Absolutely amazing, Gareth. And if there's anything else you can touch on whilst we're here today, what brings you here personally? And
yeah, so I've come as on support through the FBC Manby Bowdler, as you can see, have supported this event. Again, this car is only created from private funding, so you've got everything from aeronautical down to automotive. And so, as I say, this has got like airplane rocket jets inside it. The level of engineering is absolutely fantastic, and if people like FBC didn't support this car wouldn't be here to be trialled and tested today.
Thank you. Milton, what an absolutely unbelievable day here today already. I mean, the trials haven't even started yet. I'm really looking forward to this, and I've heard that they will move your organs, literally.
Absolutely, yeah. I mean, I don't know if you've been anywhere near a fast jet before, or let alone a fast jet with an EJ200 Typhoon engine in, but the shock waves that come off the back of the engine when it's in full afterburn, or reheat as we call it in the UK, is pretty impressive, and yeah, it will shake your internal organs. It's brilliant. Yeah.
So what is this? Is it a rocket? Is it a jet? Is it a car? You're the systems engineer, and what is your role, and how does it all work?
Well, you've just named all three items there. So the car at the moment isn't running a rocket because we're just doing the slow speed trials, but we're just operating with the EJ200 jet engine in it, but normally it would have a hybrid rocket in it too. It's probably 50-50. It's a half jet, half Formula 1 car, if you like, because it's a mixture of both the technologies together, which is great because the whole team is comprised of aerospace engineers, Formula 1 engineers, mechanical systems engineers, so the whole team works really well. I'm one of the systems engineers, a small team of systems engineering. We're responsible for the black magic in the car, if you like people call it, black boxes. So that's what we do. But yeah, it's awesome. Yeah, it's a really cool piece of kit.
So the innovative technology and what you're involved in is getting the Typhoon engine to communicate with the rest of the car. Is that correct?
That's one of the aspects, but we have to build the whole system from scratch. So that's the loom design, the wiring, the electronic control, the boxes, the PCBs. The soldering of the components on the PCBs, the coding of the software, to interface with those boxes. But yeah, I mean that is one of the impressive parts of the vehicle is that one of the systems guys wrote the code to integrate the Typhoon computer or Typhoon engine into the rest of the system on the car, because all the information off the Typhoon engine feeds into the rest of the systems in the cockpit, so the driver, Andy Green, knows what he's looking at. Yeah.
Fantastic. And for British engineering, British manufacturing, I mean, does this get any better?
I don't think so. I think Bloodhound is a project that helps to put British engineering on the map quite nicely, I think. And you've seen yourself from the reaction today and all the supporters and the press and the media. It's brilliant, really good.
Yes, it's a pleasure to meet you today. You used to be a marine biologist and now you're involved with the Bloodhound SSC, the fastest car in the world. Can you tell me a little bit how this transaction took place?
Yeah, definitely. I mean, all of my aspirations when I was younger, anyone could tell you my room was covered in dolphins. I knew 1,000,001 facts about sharks, all of them totally useless, but I wanted to be a marine biologist, that's what I loved, until I met the Bloodhound project. So they came into my school, they did a talk, they had kind of a couple of videos and things about what they were doing, and it just ignited this thing in my mind that was like, I just wanted to ask so many questions. I had to go out, I had to research them, I had to answer them, and at that point I went, well, actually maybe I'm thinking a little bit more like an engineer here, and from there it really took off, and I am where I am today because of this project.
And how long have you been working on this project?
So I first met the project in 2008, but I got involved as an ambassador in about 2010, and I've been kind of involved with it ever since.
That's absolutely amazing. And how important do you think projects like this are for the younger generation looking to get into engineering?
It's an incredible opportunity for the younger generation to be able to showcase the fact that these guys are truly pushing the boundaries of what is possible for us to do. I really think it's so exciting that the younger generation can't not be interested in a 1,000-mile-an-hour car. It's just so cool.
Neil, it's thanks to you we've got an invite to see Bloodhound SSC. What's your involvement?
So I put my son's name on the fin about 5 years ago, and that's when I first got interested in it. And then when I moved to FBC a couple of years ago, discovered that the Sunbeam Slug, which was manufactured in Wolverhampton, was the first car to go above 200 miles an hour. And so we decided that we'd keep the land speed record and Wolverhampton links together, and we'd sponsor Bloodhound. So we're a composite club sponsor.
Okay. And we have seen your logo. Have you seen it yet?
No.
Yeah, don't worry, we've got footage of it for you. So, Neil, it's just a quick thank you. We're going to interview some of the guys today, find out more about Bloodhound, and then obviously watch it do its trial run. Thank you.
You're welcome.
Liam, we're at the Bloodhound event today. What an unbelievable day. And this is the pinnacle of UK engineering and engineering across the world, really. Why is it so important to you personally to get children involved in engineering and manufacturing at such a young age?
Something so iconic and well, it's history making today. I think it's going to inspire and engage children from a young age, and children, especially around our urban areas, I think have a skill of hands-on ability, and it's not really exposed until they're older. And I think something like this today that schools could hold on to and could kind of publicise towards all children of all ages, even from such a young age, and they could roll it out the curriculum from different angles, and it could inspire children to find their skills early on.
Good morning, Kevin. What a treat today to be here at this event. Can you tell me a little bit about what you do and what you've been working on this project, please?
Yeah, good morning. I'm Kev Murray. I'm one of the systems engineers on the project. So working on all the electronics on the car, putting all the sensors in there and connecting those up to signal conditioning and then through to the computers so that they can be analysed after the runs.
You've told me that this car has all been designed on CAD, and it's just been totally transformed in regards to how it's been manufactured from from its predecessor.
Yeah, absolutely. The previous car was very, shall we say, agricultural, and this has all been done on CAD. This is the state of the art. We've got 7 computers on the car, and we've designed our own circuit boards to connect the sensors to those computers. We've got over 300 sensors on this car for the low speed runs, and then when we take it out to the desert we'll have over 500 sensors on there.
Blimey, it's just unbelievable, really. I can't kind of fathom out the technology, really. It's out of this world. I suppose keeping it on the ground could be a problem.
Yeah, in fact, the previous car had rockets on the nose to keep it down if it started to climb on the nose. We haven't got that. We've got years of CFD development, and we've got 180 surface pressure sensors, so that we can compare our actual results with the CFD, and we can detect if the car's behaving as we expect it to, as we gradually increment the speed on the runs.
So you're gradually building the speed up. Today is going to be the very first time that it's going to get to 200 miles per hour, and we can't wait to see that.
Yeah.
When can we expect it to do 1,000 miles an hour?
Well, as I say, it's a gradual process. So the next part of the process for us is to take it into the transonic region, hopefully next year, and get the data from the surface pressure sensors to say, yeah, it matches the CFD, and we can carry on with the next stage with the rocket program, and hopefully that'll be the following year, and we can get it all wrapped up and get a new land speed record.
Fantastic, just absolutely amazing for British engineering, British manufacturing, and changing the perception really of what an amazing industry it is.
Yeah, I mean, people tend to think of British engineering as old men, dingy workshops, that kind of thing, but we're absolutely the opposite of that, and we're the cutting edge, and hopefully that will come across in some of the work that we've done.
Thank you for giving us your time today. Bloodhound's obviously a passion of yours. You've been following it around for about 4 or 5 years, is that right?
Yes, we filmed it down in Bristol when it was in its infancy, and I guess then you have to say it was embryonic, because nobody was really sure if it was actually going to happen. No one was going to say that, of course, but that was the feeling. But there was so much passion, and there were so many good people involved, particularly from the engineering side, Formula One people that I knew from my Williams and Ferrari days, and because of that, yeah, you knew it was going to happen. And to see it here today, being wheeled out of the hangar in the proverbial way that aircraft are wheeled out of hangars when they first fly, is a very emotional moment, I think, for everybody involved.
It is, yeah, get some pulses racing. So there's so many different aspects about this vehicle, you know, the speed, etc. But a couple of things that stand out really for yourself.
Well, for me, I think a lot of people like to say to Wing Commander Andy Green, who's the pilot, the driver, what happens if something goes wrong? Do you have an ejector seat? Which is the normal conclusion. But it doesn't, because if you try to eject at 1,000 miles an hour, you have no chance at all. And the compression on the body just wouldn't sustain it. And so from day one, they've had to design a structure that means the driver will stay in the car if something goes wrong. And so they have to give as much safety as they possibly can, and strength for weight. And that is born of everything that Formula One has been doing over the last 10, 15 years, if you like, to the point where we're at today. You see a Formula One car having a most horrendous accident, and drivers can pretty much walk away from them. And that's obviously the technology that's gone into this car, and that to me is very interesting. I think the development also on the Eurofighter jet side, all the fly-by-wire electronic aspect of that, means that the job of Andy Green is even more fitting for somebody who is a wing commander and has flown Tornadoes and many other aircraft as well, because a lot of it will be management of the electronics and anticipating, for example, on the fly-by-wire, if he comes out of the throttle, it's a 2.5 second delay by the time the fuel gets shut off. So he's going to have to be programming all that at whatever speed he's going, and all that will be, it comes under the heading of being very meticulous, having a fighter pilot approach to the whole thing, whilst also being a racing driver. And that's, again, a little bit of a microcosm of what Formula One is all about. The drivers today are race drivers, but they're also playing around with a lot of switches on their steering wheels, and that's what Andy's doing. And thirdly, I think I think it's interesting to see that it's on rubber tyres here today. It's running at 200 miles an hour at the shakedown, but I think
I've got a little friend here.
Yeah, this is my son Jack. But when he does 1,000 miles an hour, he will be running with no rubber on the tyres because of the heat and so forth. So specially developed wheels for that, and that's fascinating too.
What a great day we've had. It's history in the making. As you see, people walking all over the place. It's been absolutely heaving. The cars hit 200 miles an hour. That's not what it's going to achieve in the end. It's going to be 1,000 miles an hour, but that's in South Africa in a year or two's time. This is just the first test run, and it's gone to perfection. You can see in the background Andy talk about what's going on. We'll have to ask him to talk down a little bit so we can actually finish up. But Gio, what do you reckon today?
I just think it's brilliant for UK manufacturing to show how amazing UK manufacturing is, that we're pioneers in what we do.
We say manufacturing and engineering.
Exactly, yeah. I mean, all types of engineering go into a car like that, and all different types of technologies. I mean, that is the pinnacle of engineering. I mean, to be able to keep something that weighs 7.5 tonne on the floor going at 1,000 miles an hour is just phenomenal.
So look, we're going to finish up now because people are walking past, you see, but we want to get it right, and there's so many people, it's going to keep happening. So that's it. What a great day, history in the making, and we look forward to seeing it hit the 1,000 miles an hour very soon.